me? Okay. So I'm glad to be back here, and there's no snow this year. Last year I came in, there was half a meter of snow. And this year I'm going to talk about Microsoft loves Linux on Azure. A lot of this material comes from other talks that are more detailed, that are about an hour. So if you have any particular area in this talk that you're more interested in, I will point you at that particular talk for a lot more details. They're not, other talks are not by me. Here's what I'm going to talk about. Give you a little background about Microsoft and Linux. Talk about orchestration of the cloud, containers, the secure VMs initiative we have, accelerated networking, which probably the thing I know most about, and what kind of the future plans are, or more importantly, what the future philosophy is. So I'll start. This slide was actually put up by Satya Nadella back in May of 2016. The funny thing is, does anybody know how long Microsoft had been doing stuff on Linux? Over 10 years. Not only that, in 2012, they were one of the top contributors for one release. But that was kind of like a minuscule thing. The reason is because they were moving a whole bunch of drivers around, so that counted. But the reality is internally, many parts of Microsoft were using Linux, especially people that we acquired. It's not a secret that, for example, Skype runs on Linux. And several other services in Microsoft run on Linux. Well, obviously LinkedIn does, that we acquired as well. And this was all kind of there, but in basically the previous regime, that was never on the agenda or radar. So what happened when we got a new CEO, Satya Nadella, and he refocused the company. He basically said, we need to focus on what our customers want, and Linux was one of those things. It was actually, I was surprised to learn that it wasn't like a big, grand executive decision. It was Satya and I forget who the other one was. We're in a meeting and our customers want Linux. Why don't we do Linux? It was that simple. And it has grown. Does anybody have a wild guess? It was announced yesterday. How many deployments of Linux what percent of deployments of Linux are in Azure? Or Azure deployments are Linux? It was a third, it's now 40%. And it's growing faster than the Windows side is growing. So I would not be surprised if by the end of the year we're at half of the Azure instances are running Linux. And so that's just, it's very, very important is the bottom line. And all the base level animosity is gone. The other thing to realize is that Linux is spread all across Microsoft. It's not just the team that I work in. We have no little Linux core center of expertise. I find in my job groups using Linux all over the place, and that's a good thing. We don't want to have only one person using it, one person knowing something. If somebody starts a new project and they decide to put Linux on a toaster, that's great. But I'm not so much talking about Linux on toasters. I'm talking about Linux on Azure. And everybody who's dealt with clouds knows that the whole cool thing about clouds is not bringing up one server, it's bringing up thousands of servers. So orchestration is kind of key. And the thing I want to make it clear about this is we don't tie you into one Windows platform that is the only way you can orchestrate Azure. The front door to Azure is the Azure portal. And this is the screen where you can choose what VMs you want to create. And it's important to note that in addition to Windows Server, there are over 20 different distros you can choose from. So it's not like you only have Red Hat or only Ubuntu. We have all the
most standard distros, and there's nothing that says you can't set one up, bring your own. It's a lot harder, but that's your own work. The other thing to realize is that this isn't the only way you can create VMs, or more importantly, you can use a template. So you can take a instance, you make a template, and you can clone it many, many times. You can even set up a cluster of instances. So if you had an application that uses 4 servers and you wanted to have 100 of them, you can do that. And you can make a template that has those 4 servers. And the templates come out as a JSON, and there's a whole bunch of tools to let you edit them and fill in all the fields. So you can even make a form that says, I fill in these blanks, and then from these templates you can create new machines. In fact, to set up some of the instances I need for testing with multiple networks, somebody just sent me a template that said, do this, and it's a lot easier than figuring it out myself. But from a CLI point of view, we're also agnostic. You can do Azure CLI on Linux, and gives you AZ command and a bunch of options about creating VMs and changing virtual networks and changing infrastructure. Or you can use, on Linux we've also taken, and they took PowerShell and open sourced it and put it on Linux. So you can use the PowerShell module. So on Linux you're running PowerShell to configure Azure if that works. Obviously on Windows you can use PowerShell with the PowerShell modules, and these two are the same. Or if you want to, you can use Windows Subsystem for Linux, which gives you a bash prompt on Windows. And here's some examples. This is what the Azure CLI looks like. This is the first time, this is the help screen. But basically you say AZ command, and then you have a bunch of subfields which you can use to configure things. Or in this case, this is a Ubuntu screen and running PowerShell, and you have the list of modules you can run. So you can say, this is an example of Windows Subsystem for Linux, which is something that was released last year, which is basically a extension to the Windows kernel that allows running pretty much natively Linux applications, in this example Bash. By default with Windows Subsystem for Linux, you check the box, you get a small instance of Canonical's Ubuntu, but there's nothing that says you can't also have other distros. In fact, I think in the store now there's ability to choose other distros. So this is, up here we have, the picture is Ubuntu, and this one's SUSE with a little gecko, and down here's Fedora. And this is actually surprisingly useful, and the way I use it is it's a really good way to get access to things like SSH into machines, or I even use it with Git and editing. So I pretend I'm on Linux on my corporate laptop. The other part that Microsoft has invested quite heavily in is containers. And it was kind of a shock to the world when they announced last year that they're supporting Docker on Windows. So you can support the same container technology running on Linux or Windows. And it's actually a little more complicated because you can take the same container and run it either natively, obviously, or you can run it in VMs on both of them. This is a slow slide. Is it going to come? There's one slide here that takes long to transition out of the way. So basically, you can take Linux containers and you can run them on HyperV. And the idea here is that you are basically taking the HyperV and you're taking a small instance of Linux and running a Linux container and for your application. And you can also run the same thing on a Windows environment. There's nothing that binds you to a particular Linux kernel. There's nothing that binds you to Linux or Windows. And it even works on Windows 10. The reason that they do this is it provides you the isolation of a virtual machine for your container. And I don't know if you know, but Microsoft is very paranoid about security, and they believe that it's really important to use virtual machines to get that protection. But you can also run, obviously, since you have Linux kernel here, you could run multiple containers on the Linux side. There's no. This is an example of, you can also on Azure, there's a Azure shell, which is actually a web app, and you can create, this is a demo that Sean had done, where he's basically creating containers on Azure using the Azure shell with a container hello world. And the point is, there's nothing that particularly, that Azure supports both containers and VMs, and this is, he's logging into the new Azure container. I'm not really going to spend a lot of time on that. The other thing is, that was important, I mentioned security before. A lot of people want to have a more secure VM environment. What do I mean by that? If you're running a virtual machine in the cloud, or maybe even in a corporate environment on Windows Server 2016, but I'm going to talk more about the cloud, you may want that VM to not be touched by the administrators of the cloud. That means that you encrypt all the data on the disk, you have a trusted boot path to create that instance, and with hardware support, you can also make sure that the admin can't read into that VM. This is really important to a lot of customers. They don't trust anybody. They want to make sure that there's no way that the cloud provider can access their data. So in this case, the Fabric admins cannot access the guest virtual machines. The hosts, we also make sure that the instance that's getting booted is booted securely, and that it's not malicious, and that the tenant VMs are also not exposed to any attacks on their storage or networking. Actually, we use the TPM to get the trusted platform module is used to validate that VM is booted securely, but we don't actually export that TPM to the guest. All data in the VM is encrypted. So we use disk encryption, the standard Linux disk encryption on the Linux side, de-encrypt, or BitLocker on the Windows side. All the state and migration information is encrypted. So if if you migrate your VM from one location to another, you want to make sure that all the traffic during the migration is encrypted. The Fabric administrators are locked out. So basically, if you have host admin access, you still can't get at what's on the VM. And you can't go inject something into the kernel on that machine. This basically says the VM knows that it's being run securely on Azure. So it's both ways, right? We have to make sure that the VM is safe to run, and the VM wants to know that it's run in a safe environment. The note down here is that there's nothing about this protection, this security that protects the VM from the outside world. It still has a network connection. So
it still could obviously be broken into if it was insecure, or it could be get a denial of service attack. It's up to it to protect its network connections. There's a more advanced drill down. These slides are from a talk that Michael Kelly gave at the Open Source Summit in Los Angeles. But basically, the start of the secure VMs is done by validating during an init-ramfs and a shim module, which is Linux Secure VM Load, that's a precursor to the normal boot process. We don't actually do any modifications to the Linux environment itself. We're only doing modifications to getting started. So HyperV supports these Linux shielded VM, and it works with the Linux distros that can support UEFI secure boot. And like so many other technologies, we work with the distro vendors to make sure and help them out to get this successful. You can also do it on Windows today. You can get commercially available. And I expect that you'll see many more of these available in the store, that you'll be able to just say, here's a secure version of, I want to get a secure VM version of RHEL, checkbox, run it. I wanted to talk some about accelerated networking. And accelerated networking is a feature that we've rolling out. And I say rolling out because it's available, but right now you have to do some steps in the CLI to say, I want it. So you basically have to say, I want to be in preview mode, that I would like this feature. And the reason that it's still in preview feature is that not all the distros in the store, the Azure store, support it. And so until we are assured that the customer can't choose an image from the store, then turn on the accelerated networking feature and then have it break, we will keep it in preview mode. It should be by the end of the year that all the main distros are supporting it. To enable it, you can obviously do it through the CLIs. If you do some web searches and do some things, you can find out the CLI commands that when you set up a network, you choose accelerated networking. The simple one is if you're in a portal and you're creating a new VM, which is what I was doing here, there's a little checkbox that says, I would like enable accelerated networking. And so I told you that. What does it do? The HyperV networking and Azure networking model now is that without accelerated networking, a VM talks over a virtual network, over the virtual bus, VM bus, down to a virtual switch in the hypervisor. And that virtual switch also is connected to a network card. So obviously this goes through several layers of software on the host, and both VMs, actually typically most VMs would talk to the same virtual switch, but if there were different locations, it would be. With accelerated networking, what we do is we pass through with SRLV, which is secure root I/O virtualization technology. We pass through a slice of the hardware into the guest. So internally, Azure uses right now 40 gig network interface cards that are capable of doing SRLV. Also, internally in Azure, there's FPGA support to allow this as what to accelerate this as well. And why would you want this? Well, here's a graph of the throughput in gigabits a second, and this bottom is number of connections. So with the normal non-accelerated blue path, we do actually get up to 25 gigabits at 16 connections, but it rolls off pretty fast. With the accelerated, the red, get up pretty fast, stays up, and then a little bit rolls off. There's a couple things to note here about this graph. First off, why is it max at 25 gigabits when I said we had a 40 gigabit network? That's because the host configures rate limiting on the network card.
В сетевой карте. Почему так? У нас здесь поддержка здесь на хосте с тем, чтобы можно было...
Other guests on that host, so there's a rate limit of 25 gigabits. We get much better if in the engineering world, obviously the Fabric host admin can go, just like your ISP can take the brakes off and give you a really fast network connection. We can test with a really fast network connection, but you'll see is max 25 gigabits. The other one is this little roll-off out here with large numbers of connections. We're still investigating. The current belief is that it's more towards the firmware side of the network interface card, and that should actually be fixed fairly soon. So not only can you do this accelerated networking with regular networking, but we also worked with the partners Mellanox and SixWin to make this work with the data plane development kit. So normally this path here is how it all works with regular Linux networking. So basically there is a synthetic and a VF path, and all that is managed. But with the DPDK, we wanted to be able to let the user space application get at both the fast path and the slow path. And these two new pieces, the fail-safe poll mode driver and the tap poll mode driver, were created to allow that to work. We have several networking vendors that are interested in doing this. All this is upstream. It's in the current DPDK release, and we're obviously working with partners and people to refine this and make it better. If you want more information on this, I was at the DPDK User Summit in Dublin about a month ago and talked about all this in way more detail, but that was a half-hour talk, and I didn't want to go on too long. So I'm way ahead of myself here. Oh, well. I'll get to the future part. First of all, organizationally, on Azure, we've made a corporate commitment that as new hardware and software features roll out in Azure, they will be available on Linux and Windows at the same time. To a customer, that may not seem like a lot, but internally, that's a big shift. Because usually what would happen is they would roll it out on Windows, and we would work to catch up with Linux. And now we're working together on all the new features. So there's a lot of cross-functional synergy and a lot of good support all throughout the organization. And we also get a lot of questions like, why is Linux faster than Windows on this? And things like that show up all the time. The process, we work upstream first. So you saw the DPDK, you saw in the Linux kernel, we work really hard to work with the community to get the changes that we want to make upstream and reviewed before it gets pushed down to customers. This has worked really well. We've gotten a lot of really good feedback, and it's really helped us. Also internally, we have a lot of test environments that are basically testing the upstream kernel before it gets released to look for problems, usually caused by other people, but before they make it out to the real world. So we have tests of both the pre-release versions and the Linux Next versions running, and my phone and other people's phone go blasting off whenever things go wrong. The other, we take that, and we have been working with a few distributions that are willing to kind of push the envelope. The one that you may have seen recently was Ubuntu. has a Linux Azure specific kernel package. And you say, well, what is that? It's basically take the upstream kernel, all those changes from the latest and greatest and the configuration and build a package out of it. So it's nothing magical, secret sauce. It's just, okay, the Ubuntu customers probably want to have the current kernel that has all the performance changes, and let's make that available to them. For the enterprise, and also Intel has Clear Linux, and the Clear Linux guys have been working with us as well. The enterprise customers move a whole lot slower, like 4 or 5 years ago. To deal with that, we have two things. One, we do work with those Red Hat and SUSE to get the upstream changes that matter to us, such as the accelerated networking, any other things, incorporated into their distributions in the next version. So, for example, the accelerated networking shows up in Red Hat, I think it's 7.4 as a bug fix. But that isn't good enough for a lot of customers that have either existing implementations or applications on older distros. So internally, we have something we call Linux integration services, which is basically a backport of the current set of drivers from upstream to older distros. So you can, for example, take the LIS package and you can get the current drivers to run on RHEL 7, or I think even RHEL 6 for the current LIS, which is several years ago, and the distro vendors don't want to get into backporting drivers, but we have people that want the current performance, accelerated networking, et cetera. There's no magic here. It's just we are working really hard to make Linux successful, and it goes all across the company, and it goes all across the infrastructure, so from relationships with partners to support to the store to CLI to the container working groups, and we're trying to work together as a team to make it possible that Linux runs better on Azure than Windows does, I hope. Thank you. I've got plenty of time for questions, and I also have stickers for anybody who has any really good questions.
Thank you. Okay, very interesting. So it's time for questions. I will be here. Please hold on.
Yeah, good. So I have a question about the Windows subsystem for Linux. Does it somehow map to that Interix and like POSIX API of the Windows kernel? Do you have any idea about that?
I kind of know how it works. What it did was, if you're familiar with basically the old NT kernel, there in Windows there's the NT kernel, and then there's what we in the Linux side would call a system call layer. And actually, there's a library as well. So what they did was they invented a new system call layer into the NT kernel that is basically the Linux system call layer. Yeah. So basically, if you do an open in a Linux process, it does a Linux open in the end, and it does all the semantics of an open on the file system in the kernel. And there's a bunch of other kind of shim magic they do to deal with, like, oh, I want /proc to appear the same as it does on Linux, and they do an amazing job of it. And yes, I'm the IP route maintainer, so I know some of the corner cases where, you know, it returns no data, not supported, whatever. But I can run Emacs. I can run pretty much anything that you would normally run as a user. What? You can even run fuzzers and things like that. But, things like I want to configure a firewall rule, it's not going to work that way. Yeah.
Thank you. Next question.
So other question, if you don't mind, about this Windows subsystem for Linux, which I like from the beginning, like which is the name Windows subsystem for Linux. Windows not.
I know the
device
answer to
servers.
that. Let me just say it's.
No. It was just like introduction. So the question is, what about support for device drivers? I mean, okay, I like that system, but I want to access at least serial port on my laptop, for example, where I run that VS Windows subsystem for Linux. Any plan for that? May I expect it?
Okay, let's go back a couple layers. And I'll start with the last exercise. Is I don't think you'll be able to access the serial port directly right now, but I'll explain a couple things that might let you do it. The first thing is, why is it called Windows Subsystem for Linux? I was surprised to find out that marketing makes up the names, and every name that they want to make up has to have Windows as the first word. So it's Windows Subsystem for Linux, so Windows is first. Okay, that's marketing. I was talking to the developer of this, and I had this kind of crazy idea of being able to run on my corporate laptop Windows Subsystem for Linux, and being able to debug a Linux kernel running in a VM. Because it turns out that if you're familiar with Linux, you can have the serial port and KGDB. So it turns out that HyperV presents the serial port as a named pipe in Windows. It turned out he also, for some other reasons, had done a program that takes that named pipe in Windows and turns it into a virtual serial port in Windows Subsystem for Linux. So we haven't actually done it. We're still working on trying it out and setting up the environment to test it, but in theory, it should be possible to do that. That reason I brought that example up is it's possible that you can write a small program that acts as an intermediary between Windows environment objects and, in this case, a sudo TTY in the Windows Subsystem for Linux layer. It may not be the most performant solution, but you could do that. And the example of that program that he did to get the sudo TTY out of the name pipe is on GitHub. And I can probably send you a link for that.
Okay, thank you. And actually, the main question was, probably I don't understand quite right, but that Windows Azure, this is something really Windows-based, right?
Okay, I should probably have gone back. Internally, Azure, what it is they took a version of Windows Server, stripped it out, threw a whole lot of orchestration on top of it. So underneath the covers, it's Windows Server. It's not a version that you buy at the store, and it's partly because the hardware integration and partly because they are always rolling it out. But it's very close to Windows Server 2016. In fact, that's what I use to test kernels and HyperV.
Okay, again, it was just introduction. So then, what is HyperV? It runs on top of that kernel?
Actually, HyperV runs below that kernel. In reality, it's the virtualization layer for Windows. It's kind of like KVM in the Windows world, in the Linux world. It basically just deals with mapping hardware resources into a guest.
Yeah, okay, so basically what I wanted to discuss, so finally if we want to run Linux in virtual machine or in container on top of all that,
yeah.
So why bother with all that Azure, Windows, Hyper-V, and that's all, if you may just have a Linux kernel and container on top of that, which requires, I think, a very limited amount of resources.
It's more about you're running a cloud. So if you're running if you're deploying on bare metal, there's no real advantage. It's more about if you're deploying in a cloud environment and you want to, A, have someone else control the resources or manage it, or B, you want to be able to migrate.
Yeah, so basically that's more about infrastructure, but not about efficient usage of your existing computers.
Right. It's more about you're using someone else's computers, right? What is a cloud? A cloud is someone else owns the computer.
And do you have any comparison between different solutions like this Azure-based and some probably open source like Virtuoso or something?
We have lots of them, but I'm not the person that has that, and I really don't have details. All I know is, the corner cases of this solution is better than ours or worse than ours on that feature, and I really don't want to get into those.
But I think it will be quite interesting addition to your presentation. Not like, okay,
Yeah.
Windows loves Azure or Linux or whatever, but here's where we are.
Yeah, there's actually, you're bringing up a good point. There's a whole nother presentation of clouds, containers, virtual machines, trade-offs, and so on. And that's a very complicated topic, but certainly worth another presentation.
Probably next time.
Yeah, if I come back, I still have another year on my visa.
Yeah, absolutely welcome.
Okay, thank you very much.
Thank you.
Okay, the next question. Okay.
Over here.
Thanks for your talk.
Yep.
As I understand, Azure environment uses the hardware virtualization, right? So it provides it emulates some hardware for the guests, right? Does it use power virtualization, or guest just doesn't know that it is virtualized?
Actually, that's a very good question. In general, it uses everything as para-virtualized. There's this bus we call VM bus in our world, which is basically a para-virtualized bus. So every device is presented to the guest as a item on that para-virtual bus, and every device has a ring buffer for requests and responses. So that's the primary way devices show up. But obviously for accelerated networking and for a few other things like the devices pass through and they show up as a PCI, a virtualized PCI device, which is basically the resources on the host side are memory mapped into the guest at a particular region. So that shows up for accelerated networking. And the other one is if you buy certain machine types in Azure, you can get them with GPUs. So for high performance computing, you can get a machine with an NVIDIA GPU, and that NVIDIA GPU shows up in the guest memory mapped.
And about this memory mapping, do you give the whole PCI device to the guest, or can you give some part of it?
You give part of it. You give a virtual SRV, you give a VF device for networking, and the NVIDIA device supports VF devices, also RDMA devices. So,
thanks. And speaking about para-virtualization, do you use some already existing drivers, which maybe QM or KVM uses for para-virtualization, or do you develop new one, mainline it?
Yeah, they've developed new ones many years ago when the VM bus was introduced, and that was the start 10 years ago. And in fact, 5 years ago, when they were number one was when the drivers became real, the Linux kernel got moved around. So these have been around a long time, and it's kind of like VirtIO is one world to deal with a virtual bus in KVM, and there's this family of VM bus drivers that exist to support HyperV.
And maybe it was the main part of Windows initiative in the mainline, right? When Microsoft was leading.
Right. So that's why it went in mainline, and they were like number one. They were like in the top 10. It was because the drivers that were in the staging tree were moved back into the mainline, and all those thousands of lines counted as being submitted by KY from Microsoft.
Thank you very much.
Yep.
So you mentioned you use FPGAs within Azure. Can you speak about that a little? Do you
yeah.
use like OpenCL or?
No,
do you use to operate
what
them?
they do is, if I go back to this one, what happens is, I didn't feel like I have a whole lot of time to do it, but this is a DBK version. But basically, what happens is with accelerated networking, what they want to do is they wanted to have the same set of software-based flow restrictions that exist in Azure also work with accelerated networking. So basically, you don't want the guest to get a network connection that it's not supposed to get. So when you configure the guest and you configure the virtual net and network in the guest, you can configure the effective firewall rules that say, I will only take these flows. So what happens with accelerated networking is the first packet shows up, and down in the host, it runs it through an FPGA that knows the rules that the host is configured. And then if it's allowed in, it actually, the first packet of a flow will go through the synthetic path up, but it also programs the hardware on the network card that says every other packet in this flow can go on the fast path. And I don't know if it's kind of like a hardware implementation of, if you're familiar with like vSwitch, like Open vSwitch and OpenFlow, they take the first packet of a flow in and they apply a bunch of rules to it. And based on that, they program the tables. So we're basically doing the same thing with an FPGA and hardware.
Thanks.
Okay, so the next question.
Right there.
I have a question about Windows services for Linux.
Yeah.
It's basically re-implementation of Linux system calls, right?
Right.
Is it written from scratch, or is it based on Linux? And what about license?
No, actually, it's all on the NT kernel. Okay, it's all on the NT kernel side. It's written from scratch because it needs, not so much from license side, but because it's got to talk in that world. So it's got to be written in C++ and all the other things. And so.
Thank you.
Okay, thank you. Any more questions? Okay.
First of all, thank you very much for the presentation. Question what I have is having the support of built-in Linux on Azure, does it mean that the pricing per VM per month is going down a little bit, comparing, for example, with the Amazon?
I'm not involved in the pricing, but the pricing basically comes down to, like any other cloud, there's the type of VM you get, and that's, I'm sure the guys pricing that market-wise do it based on just like they do commodities of pork bellies, right? GPU, whatever this size, Google Cloud and Amazon price it this way. We need to price it that way, and I'm sure that goes up and down and has corporate relationships as well. And then there's the other side, which is the software license. So obviously, if you buy a Windows VM, you have to pay a Windows license fee. And if you buy an Oracle VM, you pay an Oracle license fee. And if you buy a Ubuntu VM, you don't pay any Ubuntu license fee. So in fact, internally, there's projects that use Linux just because even internally we have to pay Windows license fees. So.
All right, thank you.
Yeah.
Thank you, Yugi. If you will not from Dell EMC, you will own the T-shirt for the question.
Yeah.
Okay. Any other questions? Dmitry.
Maybe last question from my side. Can you please tell us a little bit about how you handle QoS in Azure? You just touched that a little bit, but maybe you can explain more. How do you control the QoS, especially for things like accelerated networking, RDMA, where from what I remember, at least HyperV had some incompatibilities, like you can use software QoS, or you can use DCB, for instance, but you can't mix them, and it didn't work well in the past, I guess.
Well,
Can you please just tell us
I'm not-
about how
I'm
it
not-
works now?
I'm not the expert on that. All I know is some peripheral things. There's three sets of areas there. One is, this is a bad slide to use it, but I'll just point. If you're up in user space, obviously, in the guest, you can do whatever kind of QoS you want. Whatever the operating system you're using supports. In the host side, there's a bunch of QoS that you can configure when you create the instance. So you do have some ability to say what you want this network. The harder part, and probably what you're referring to, is the underlying network that Azure is built on and the QoS and the parameters of that. There are some limitations of that. I've seen examples of the one I typically run into is PM2 discovery kind of issues. But if you talk to me, I can get you to the right people to understand what's going on. And that is also something that those teams are taking lots of customer feedback and trying to figure out what features they can support in what regions and what to be successful. Because we obviously have many different customers with many different, needs that actually propagate all the way down to the lowest level.
Thanks.
Okay. Do you have any other questions? Okay, probably it's a question to Dmitry. What is the most interesting one? You need to think about this too.
Yeah, I will actually consult with Steven on that. Maybe Steven can do the job and pick the most interesting one.
Most interesting ones were probably some of the Windows Subsystem for Linux questions. So,
Okay.
I think you get the most interesting question.
Yeah, I know this guy. Thank you.
Okay, so Steven, thank you very much for delivering that interesting presentation during this second time when going our conference. And thank you.
Thank you.